Hi everyone, and welcome to the Global Dev Study with the topic of past, present, and the future of Python for this wonderful Tuesday night. I'm Hon, one of the product manager at Group, and I'm the moderator for today's event. In today's event, we are honored to have the core developer of Python, the release manager of Python 3.8 and 3.9, Mr. Lucas Langa, to share with us his 5 favorite new things in Python 3.10. Pattern matching, typing improvement, NX iter parenthesized with statements, and improve error message. Also, our speaker is Mr. Luciano Hamalio, the author of Fluent Python. He will share about the type hinting, the protocol, and the good sense about it, which can help the attendees to become a better Python developer. Lastly, Mr. Pat Villafore, the author of the book Robust Python, he will share about how to write clean and maintainable Python code for large code base. So before we get started, I would like to share with you on how to participate in today's event. So there are a couple of times you can ask questions to our guest speaker, and you can do so while a web app called Slido. If you'd like to ask questions, please scan the Slido QR code on the screen. And key in your questions. So that's all for the announcement. I'm going to go over to our first guest introduction. Our first speaker, Lucas Langa, is a Python core developer and mentioned just now he's a release manager of Python 3.8 and 3.9. Also, he is the creator of the popular Black formatting tools, and he is also known as AMBB on the GitHub. So as everyone knows, Python 3.10 is still in the beta stage, and Luca is in the core developer team. So we would like to hear from Lucas like what will be the change and what will be the new features in the Python 3.10. So we'll invite Lucas on the stage. Hi,
Hi.
Lucas. Yeah, if you're ready for presentation, please go ahead.
Sure. Glad to be here. All right, let's go ahead. My name is Łukasz Langa. I come from Poland. I used to travel when that was still a possibility. Nowadays, you can mostly just reach me over the internet. My website, where all my contact information is just łukasz.langa.pl. If you need to, you can omit the L and just say Lukasz. It'll work just fine as well. Like apart from just being the release manager of Python 3.8 and 3.9, just very recently I've become the Python Software Foundation CPython developer in residence, which is super exciting for me. It's now a full-time job for me to work on CPython, which has been a dream of mine for a long time, not just personally, but for the project to be able to move faster. Now we have over 1,400, so 1,400 open pull requests waiting to be reviewed and hopefully merged. We hope to bring that number down. But today we're going to talk about Python 3.10. This is not a Python version I am releasing. This is a Python version that is released by already a newer release manager. And of course, it's got very many new features. The 5 I want to focus on today are pattern matching, which we're going to spend some time on since that's the biggest change that we're going to talk about today. Then some typing improvements. That's not a single change. It's a number of incremental improvements to static typing in Python. Then the smallest but kind of important feature for me, anext and aiter. So improvements for asynchronous iterators and generators. Parenthesized with statements, which, while tiny, are kind of important in the context of automatic formatting, as well as improved error messages, which doesn't sound like a big deal until you actually see them in practice. Like, they're very impressive. So before we begin, Python used to be released every 18 months, and that wasn't really a tight date schedule. It was more like a guideline, and we did our best for it to be 18 months, but usually it was longer. Since Python 3.9, we are now releasing Python at annual release cadence. So it is very easy for downstream distributors to actually know which month a particular version of Python is going to come. This is described in PEP 602. And currently, as you can see, we are at the stage of beta, just about to become RC1 for Python 3.10. So just next week, we're going to be releasing the first release candidate of Python 3.10. So functionally, it's pretty ready. Now we're focusing on making tests and documentation better, as well as fixing remaining bugs that we discover before the final version that is going to come in October. As I said, I was releasing Python 3.8 and I'm releasing Python 3.9. 3.10 and 3.11 are being released by Pablo Galindo Salgado, who works at Bloomberg in London. He's a Spaniard, also an astrophysicist and a great guitar player. And he does amazing tricks with cards. So, like, very interesting and colorful person to get to know of. Yeah, so like Python 3.10 is his first release, so just about to enter the release candidate stage, but he's already working with the rest of our team on Python 3.11. It's going to take a while before we release Alpha 1 of that, but the main branch on Python/CPython on GitHub is already work on Python 3.11. So without further ado, let's talk about what we actually will be able to use starting October with Python 3.10. So pattern matching. To show you how that works, I prepared an environment where there's a Python 3.10 version I built just today for you. And we're going to show you a bunch of files that we can, go through to show how a particular feature works. So the first one, let's just call it, pattern matching py. And it demonstrates the new match statement. And we can see here. If you ever coded in C, C++, Java, of the switch statement. This is sort of similar, but actually much more powerful and flexible. It is not exactly the same. It is more reminiscent of like Erlang's pattern matching. So to show you how it works, it's just better to actually demonstrate it in practice than to, kind of go ahead and describe in theory. So let's go ahead. If you have an argument, which can be anything, a match statement will allow us to decide like whether it looks like something that we're looking for. For example, it might be a particular value. In this case, it's a string that has the value hey. And in this case, we're going to do something. In Python pattern matching, you don't have to use breaks and whatnot. Like that is always automatically done for you. So no issues like in C and C++. We can actually want not just a particular string value. We might want any string, in which case we can say, give me an object of this type, right? So any string, in case it is going to be some string. But we can also do much more powerful things. For example, actually matching data structures, like a list with a single element that is a string with a value of hey. There can be a list with two elements, or maybe two elements, but they have to be either this or this, right? Or maybe it's a list, and it has to have the first element like this, but the rest of those, we don't really care. Like, they can be anything. And finally, the default case at the end is just denoted by this underscore, meaning we received something else. So we might actually try this in practice, right? So if we start an interpreter, we can import this pat match thing and start matching. For example, if we just say, hey, it'll match the first case that we had above, returns hi. Like if we say something else, it's a different string. If we put this in a list, right, like it'll, it'll know that, oh, this is the case that we're looking for. Like if we say, hey Jude, it'll recognize the song by the Beatles and will tell us, hi, person of culture. If we actually decide to do something else, like, hey, yeah, I don't know, like it'll just take this argument and paste it here. Like that's this case right there. And finally, if we just say, I don't know, float of 1.0, it says we got something else. So pattern matching, pretty flexible. It allows us to parse arbitrary content that we receive from somewhere, like data over network or comments from the user, like this sort of thing, or maybe just parsing some particular data format. So very flexible. We can do much more with that. So let's go with another example that is more advanced. So say here we have a data class, that is just person, single field name. It's a string. And then we have a movie, right? It's got a title and some list of actors and some list of directors, right? And our matching test this time will try to match whether we are receiving some dictionaries with particular content. That might be, for example, JSON that you're receiving over the network. So for example, if it's JSON with a title field and an actors field that has a list and a directors field that has a list, we can match and create a movie object out of this dictionary. If we have the same dictionary, but the user put a single director in the field instead of a list, we can still match that and actually make what we need to do so that the returned object is still valid. And finally, when we might maybe match some particular movie object already. So we can actually match already what there is given by the user. If for any reason it happens to already be a movie object with those particular values, which is pretty amazing. We are actually looking inside the state of a particular object and seeing whether the title field matches, whether the director's list matches, and just, we can say something special. So again, we can run our Python and import this second thing to see what it'll match. If we, for example, say matching test, let's say title, movie, and actors, let's say I'm an actor. I don't know, or maybe David is an actor, or directors. And let's just put Guido as the single director, right, of this movie and say what it matches. So as you can see, the data class we wanted only supports lists of things in actors and directors. The pattern matching discovered that the director's field was a string with a value, and our logic that we just wrote above put this in a list in a particularly good way. So pattern matching, very flexible, super powerful feature that we could only add now to Python, that we have a better parser for it. We used to have a more basic LL1 based parser. Now, through a very big chunk of work by Guido, Pablo, and others, we now have a more flexible PEG-based parser that allows for advanced syntax like the match statement. The match statement is weird because now you can recognize, oh, match is some keyword, right? And then we have some expression, and then there's cases that actually start blocks because you have like colons right here and right here. But you can still use match and case as variable names in different contexts. Right? So for example, it is totally fine for you to start Python and just say match equals 1 and then just print match, and it'll work just fine. Like, you cannot do the same with if, right? That's impossible. So this flexibility has only been enabled with the recent change to a PEG parser. All right, moving on. typing improvements actually are about quite a few new features in typing that were only added in Python 3.10. So let's allow like the most kind of visible change for now, I guess. So starting with Python 3.9, you no longer had to, from typing, import list, right? Like to say that some variable is, for example, a list of string. Now, starting with Python 3.9, you can just say that some list is a list of strings. See, lowercase list. And that list can be for now empty, and then we can add things to it. One missing piece to this was that what if L can be either a list or a single string, right? In this case, before you had to actually go ahead and import union and say it's a union of either list of string or a single string, right? And then a single string still matches. But that is very wordy, and you have to import from typing. Now, in Python 3.10, you can instead just say it's a list of string or a string. Much cleaner, right? And you don't have to import anything. This is tremendously useful for many, many use cases, including data classes, right? Where you describe your protocol, you describe what you need your data class to hold. And with this sort of syntax, it takes less space, it's more readable. In one particular case, this is very useful, and that case is optional types. So very often we would have something like result in a function, and that result is going to be some string, but it's not yet. The original value is actually none, right? So you can now type it as string or none, and just say it's none for now. Maybe later there's gonna be some code, and after this code, like we're gonna assign some actual result and return it from our function. But now with this very shorthand syntax for or none, it is very easy to type optional types. Before you had a particular optional type that you could import from typing, but again, optional. But again, it's something that you have to remember to do. It's verbose, it takes more space. So now the pipe character, awesome. Like this is great for union types. Moreover, there's some smaller improvements like explicit type aliases. So before, if you needed to have a type alias for something that is complex, for example, I don't know, names would be an alias that is in fact a list of strings. So later, when we have a function that accepts names, we can just say the type is names, right? This is useful. This is called type aliasing. However, some type aliases are confusing to the type checker because they look like they are just regular Python expressions. Like for example, maybe like a name is a string. Like this looks like a regular assignment. So now with Python 3.10, from typing, you can import an explicit type alias, and you can say that name is a type alias and its value is a string. That way, it's both easier for people to read that, oh, this is a type alias. This is not something that's going to actually be used at runtime, but also it resolves some issues during type checking when sometimes the types would be just confused by the type checker with runtime expressions. On top of that, we have PEP 612 that allows us to much more flexibly type callables. So we got now new names called paramspec and concatenate and paramspec args and so on. Like this is useful for you if import. This is useful for you if you are typing callables with very big detail. So I recommend just reading PEP 612 or the documentation on those. We don't have time to go into that because I would just spend the rest of my 30 minutes on all those typing features. I'm involved in typing, so of course like I like those a lot, but I wanted to show you some more stuff too. One thing that is practical though is In the inspect module, now we have get annotations, and get annotations is particularly useful to, for example, get annotations of the f function that we just defined above, right? So you're gonna get the return value annotation and argument annotations, same for classes and whatnot. We used to have and still have get type hints from typing, but get annotations is more flexible right now. So this is the recommended way to deal with annotations right now. And finally, the last thing I wanted to mention is PEP 647, which are type guards. What type guards are is import again. I cannot talk and type at the same time. It's hard, type guard. What this does is allows you to flexibly create your own defined type guard for your code. So what is a type guard? For example, if you have a function g that accepts an argument, and that argument is either an int or none, right? Then inside the not for def. Inside the definition, what the type checker knows about arg right now is that it is either an integer or none. So for example, if you wrote code arg +1, it would tell you, no, this is an error, because if it is none, then it will not work actually. So what you have to do is, for example, you have to say, if arg is none, then return. And now, after this line, after this return, which is called a type guard, now the type checker knows that now arg has to be an integer. It's gotta be an int, because otherwise, if it were none, we would already return. So now like arg +1 is valid. The type checker won't have any issues. So type guard that we imported from typing here allows you to create new functions that serve as this sort of thing, as flexible type guards, because sometimes this is going to be different depending on your custom business logic. So now you can define this flexibly, and by this you can inform type checkers that your code does something special. All right, moving on. Anext and Aiter. So let's actually go into async.io REPL for this one. So let's say we have a very simple ticker. Like that ticker is going to just let us return a bunch of values from 0 to 2. We're gonna yield those. So it's an async generator right now. And we want to kind of show you that it's async. So it's going to randomly wait some time. Let's say like between 100 milliseconds and 10 seconds. And now we're just awaiting, like, sleep. This is like an obviously dumb example, but usually instead of the sleep, you would have some networking, right? Like that is happening. So it is actually costly to do this operation, so we await. So we have asynchronicity, so we can do many things at once, right? So we have this sort of async generator. Before, we didn't have the ability to easily say anext on it, so just to get the next value out of a generator, but now we do. So if we define a particular instance of this ticker, say t ticker equals 10, now we can say await anext t, and it'll actually return us thing. Yeah, see, like sometimes it sleeps for a long time, sometimes it doesn't, maybe like until like 10 seconds, right? We'll see. Yeah, took us a while, but it returned the next value. And it works like this. So like the inclusion of anext and iter, it just makes them more natural to use. You don't have to use dunder methods anymore, which are somehow, feel magical and make the code less readable. So now anext and aiter are there. So asynchronous generators and asynchronous iterators just look less magical when you're using them. Moving on, parenthesized with statements. Like this is pretty easy to show actually. Let's just leave the async.io REPL, go back to a regular Python. Say if we actually make a new context manager, You can do that very easily with the context manager decorator from ContextLib. Say context manager test. Let's just add an argument to it. Like usually that context manager will do some initial work, and then it's going to yield some value, like let's say it's this argument, and then it'll do some cleanup after, right? And how you use this is you say with our context manager test, you assign some argument, maybe it's a very long string, and then as context 1, and it's 1 because you might want to have many maybe. So context manager test argument equals a very long string 2 as context 2. Like you obviously see the problem already, right? Like it's kind of very busy and a very, very long line. So the problem here is that there was no way to very nicely format it before. It was impossible for us to do this. Now we can simply put each of those inside a nice parenthesized expression, and through this make it much more readable. And that in Python 3.9 and before would return an error, and now it's possible, and obviously formatters like Black will be very happy to format stuff like this for you. Yeah, so small feature, but improves readability a lot. And speaking of improving people's lives, like error messages are kind of amazing right now. So let's go back to the past for a second and see a bunch of things that we can do in Python that are wrong. So they generate errors, like say datetime, date Tim. And it says, okay, like there is no attribute datetime on datetime. Okay, maybe we want to say if x equals 2, but we forgot one equal sign. Let's see what that will say. Oh, just invalid syntax. And if we say if x is smaller than 10, it will say invalid syntax. So like very basic. It does say what's wrong, but in a very, very crude way, right? Let's move to the future right now. So Python 3.10 and do the same thing. So datetime, date Tim. It'll say, okay, datetime has no attribute date Tim, but it says, did you mean datetime? Which is pretty amazing. It looks for similar attributes in that same namespace and suggests one for you. I find this very cool. Same with if x equals 2. It'll tell me it's invalid syntax. That's true. But it will also tell me, did you mean an equals operator, or maybe the assignment expression, right? This is super helpful, especially for newer developers. But even for like, very advanced developers, it's still great because it'll just accelerate your debugging. Including stuff like defining new blocks. If you forget the colon, it'll just tell you it forgot a colon instead of saying invalid syntax. And there's a bunch of other nice improvements, like telling you to use parentheses over tuples in comprehension targets, and kind of telling you when you forget commas and whatnot. In fact, like I have one particular example for you here for this. So better error. Let's open this in Visual Studio Code so you can see it. So if we have a longer module like this, right? Like there's some data defined here, there's some public functions, and it does something, right? Regular Python module. Like if we executed it in the current version of Python, Python 3.9, it'll tell us that def main is invalid syntax. Well, technically it's true, but it doesn't tell us what happened. So Python 3.10, it will be different. It will tell us that this particular opening parentheses, this one, was never closed. This is pretty amazing because we can easily fix this by, say, adding another core developer and closing this here and running it again, and it'll tell us, oh, I forgot a comma. That's pretty amazing. It'll tell us here, you forgot to put a comma. That is great. In Python 3.9, like it would be a little more confused. It would just say that here Z where is invalid syntax. Like, well, the actual error is here, right? Like it's forgetting a comma. So Python 3.10, much more helpful for you. I could go on because this is quite amazing, but I'm out of time at the moment. So I would just like to invite you to just contact me if you would like to do anything with CPython. There's plenty of ways to contact me on my website. I also have like weekly reports now on how I do with the developer in residence position. So if you would like to know like what I'm up to, like how I spend my week, just go ahead and check that out. Thank you very much for your time.
Yes, thank you, Lucas, for this very insightful presentation. Actually, I like the error message part very much because, Python is always very friendly for the beginner, and this improved error message help it more to make it like even more user friendly for the beginner. And
Fully
I
agree.
think that yes, and I think that the pattern matching part is very useful because when I'm using a Java, the switch is always very useful, and I'm very glad that Python 3.10 finally we have these features. Cool. So if all the audience if you have any questions you want to ask Lucas, please scan the QR code and ask the questions. So now we'll be showcasing a video about Forkwell, and then we'll have a rest time until 9:10. Yes, please enjoy.
As a software engineer, are you truly getting valued for your skills or for the market value that you deserve? Let's take a look at Show's life. Show is a software engineer who has worked on many well-known and successful projects, but he is hasty, worried, and agitated. Why? Because his inbox is constantly flooded with spam from scouters, which they have, obviously, copied and pasted, and the good ones tend to get lost in the long list. That is why we are introducing Forkwell Jobs, a scouting service for software engineers that will solve your problem. By removing simultaneous transmission functions, we eliminate spam scout mails for you, allowing real scout mails that actually match your career. If you are searching for a new job, you will be able to see the possibilities your career holds. And even if you are not looking for anything new, knowing your career's worth will help you see possible choices, such as wages and new career paths. Our portfolio can provide you with a straightforward and correct registration process, making it much easier for you to get an adequate scout. Making it easier for talented people like Show to quickly find and respond to the emails that will help them advance in his profession, while the spam emails are eliminated. So, if your marketing value appears to be being buried due to hundreds of copied and pasted emails, sign up for a Forkwell account and request a scout today. You can meet with the recruiter in whatever way you choose, whether it's through an online meeting, a visit to their office, or a formal interview. Our services are easy to use, free, and offer you a calm and productive platform where you can concentrate on building a successful career. So, stop wasting time and hire a real scout at Forkwell Jobs today to give yourself the marketing value you deserve. Forkwell Jobs, create a new career.
welcome back to the Global Dev Study 5th event. So I would like to introduce Luciano Ramalho to you all. He's the author of Fluent Python, which is published in 9 languages. So currently he's working on the second edition updated for the Python 3.10, which is scheduled for late 2021. Luciano was the first president of the Python Brazil Association, and he is a fellow of the Python Software Foundation. Also, he's a principal consultant at ThoughtWorks. So I will pass this over to Luciano. So if you are ready, please go ahead.
One moment, I'm just sharing my screen. Okay, I think, yes, all right. Well, thank you very much, Hon. Thank you very much for the Forkwell organization. I am very proud to be, I'm very honored to be speaking at an event in Japan for the first time. Yesterday, to celebrate, I ate sushi during lunch. I love Japanese food. So anyway, let's get started. So my talk, Type Hints, Protocols, and Good Sense. And one of my motivations to write the talk was this tweet by Raymond Hettinger, who is a famous core developer. And he said that he hoped there was more balanced reporting about experiences with typing. And the second paragraph there, I actually agree, because I watched during research for writing my book, the second edition of my book, I watched 9 different talks at major Python events online about typing. And they were really all presented by people who were typing evangelists. So I felt that there was a need for people to talk about, you know, what are the issues with this? This is great, it solves lots of problems, but probably there are some downsides. This is my book. This is the Japanese edition. Like Hon said, it was published in 9 languages. And this is the second edition. I'm finishing the review of it. It covers Python 3.9 and 3.10, including pattern matching, which Lucas presented, and it's my favorite feature by far of Python 3.10. It also includes more than 100 new pages about type hints, and many examples, even in the chapters that are not about type hints, also have type hints. And there's updated coverage about async await, and the draft you can read now at O'Reilly. You can get a trial or subscribe to their learning service. The draft is there. But the book is going to come out for Kindle and in print in the last quarter of 2021, if all goes well. So, and this is also, I'm going to share with you things that I learned while I made a few contributions to the official TypeShed project. So the TypeShed project is a repository in the Python organization of GitHub that has type hints for the standard library, okay? Because the standard library, as of Python 3.10, doesn't have type hints yet, but the tools like the IDEs and MyPy and the type checkers need the type hints. So TypeShed is a common repository with those type hints. And I'm going to actually show you 2 things that I helped fix there that illustrates one of my points. And I also helped reorganize the typing module documentation. So my talk is going to be split in basically 3 parts. The first part is about the 4 modes of typing in Python. Second is the central role of typing protocol. And third is typing limits and how to address them. Okay. So the 4 modes of typing in Python. Everybody that knows another language besides Python knows, well, maybe a popular language, for instance, is Java or C# or C++. Those are languages with static typing, right? And then we have Python and Ruby and JavaScript. There are languages with dynamic typing, right? This actually has to do with when the types are checked. It's wrong to say that Python is untyped or that Ruby is untyped. They are typed, but the type checking happens at runtime. The only fully untyped language is really machine language, right? Where the bytes are just bytes and it depends how they are read. But every other language has some kind of typing, even if it's not explicitly with annotations. But the point is, static typing allows static checking. That is, checking of the types by just looking at the source code, which is what MyPy does, or PyCharm, or VS Code, right? And dynamic typing has to do with runtime checking. And this is not a binary choice. It's actually a continuum because of a new development that I'm going to talk about soon. So then there's also another thing called duck typing, right? It's somewhat related to the dynamic typing. But it's the idea that you don't check whether something is a duck, but you check whether it quacks like a duck or walks like a duck, depending on exactly what subset of duck-like behavior you need. For instance, in the Python documentation, for many years, you have sentences like a file-like object. So what does that mean? It's an object that behaves like a file, but it doesn't need to be a file. And in some contexts, a file-like object is just an object that has a read method that when you call returns bytes. That's enough to be a file-like object in some contexts, right? So this phrase, the idea of duck typing, was popularized by Alex Martelli. Wikipedia recognizes him as one of the first persons to write about duck typing. So now we actually have a map, because we have on the left side, we have static typing, and on the right side, we have duck typing, but also there's above and below, right? The top side has to do with structural types, and the bottom side is nominal types. So what does that mean? It means that when static typing in the Java style, and now I added these informal definitions here, Java style and Python style. The Java style is to do static typing based on nominal types, which are types that are explicitly declared. You say that a class implements an interface. You say that a class implements or extends another class. This is all explicitly declared in the code, right? So that's the idea of nominal types. And of course, you have now two empty quadrants here. But Python also supports something that Alex Martelli calls goose typing, which is the idea of doing runtime checks based on nominal types. You create you define an interface by creating an ABC, an abstract base class. And so that's a nominal type, and then you declare that a class is a subclass of a certain, like a sequence or an iterable or something. And then that allows, at runtime, it allows you to do checks using isInstance or isSubclass, but also allows the static checkers also can use those ABCs as nominal types, right, for static typing. And then a very important thing, now Lucas, who was just speaking to us, is a really huge contributor, and we have to thank him and applaud him. He is one of the authors of PEP 484, which introduced type hints, and he is also one of the authors of PEP 544, which in my opinion was very important to bring the philosophy of static typing in Python more in line with the practice of Python, which is duck typing, because protocols allow static duck typing. Okay, and we're going to talk a little bit about that. So this is the complete map, right? So you have static duck typing is supported by typing protocol, which is a special class that you subclass to create protocols. I'm going to show how to do that. And I can illustrate this, but looking at other languages, right? So Python is one of the few languages that appears in all 4 quadrants. TypeScript also appears in all 4 quadrants. The Go programming language is a statically typed language that has also always implemented static duck typing via their interface mechanism, which is very similar to the protocol mechanism that we have in Python. And it's very important to remember that in the PEP that they wrote, Guido, Yuka, and Lucas wrote that Python will remain a dynamically typed language, and the authors have no desire to ever make type hints mandatory, even by convention. So actually what happened was PEP 484 introduced in Python a gradual type system. And there are other languages that have a gradual type system, or that implement gradual typing, like TypeScript, like Dart, and Hack. Okay. So, and the best feature of gradual typing is that type hints are always optional. You know, you can omit type hints, or you can disable the type checking on single lines, on functions, and entire packages. And this is very important because it makes it easier for us to work with legacy code, but also even when you're writing new code, sometimes you will find that some things are very hard to annotate, and some things are actually impossible to annotate. Well, let's talk about the central role of typing protocol. So when I was doing research for my book, I found an issue. I filed this issue on TypeShed because I found out that the type hint for the statistics mean low or median low and median high functions were wrong, because they actually worked with other types. For instance, I could ask for the median low of a sequence of lists, right? So it would pick the middle elements of the sorted list, or if there's an even number of elements, median low would pick the one to the left, or the one closer to the beginning, right? And median high picks the one closer to the end. Okay, so I found this bug, and this bug is an example of a false positive. Right, so you can see the red tag on the right there that the TypeShed people classified. So a false positive means that the type hint is making the type checker report an error where there is no error. Okay, so that's a false positive. And how can we fix this? So I wrote a test. Okay, I actually copied the code of median low, and I experimented with it, and so these are 2 tests. The first tests whether median low can find the median of a range of integers, and the second the median of a sequence of characters, right? And if I run this, what happens is the tests pass. So this means both of these things work. But MyPy complained that the type variable number cannot be a string. So that's the false positive, right? And so this was, the old code was declared like this. On line 6, you can see that they had declared a special type variable called number, and number had to be a float, a decimal, or a fraction. And that includes an int, because int is a subtype of float. Okay, so that was the problem, line 6. And to fix what I did was I created a protocol. I called it sortable, but afterwards we renamed it to supports less than, following a convention that Python is adopting. But anyway, so the sortable protocol. So look at that. It's a sortable is like a subclass of protocol, but protocol is a special class that's designed to allow you to create protocols. And a protocol is a class where the methods don't have bodies. You see those 3 dots, that's valid Python syntax, and it just means that we are not revealing, it doesn't matter what the body of the function is. What matters is, to be sortable, an object has to implement the dunder LT method, right? Under LT, under we say dunder LT, which is the method that implements the less than operator, right? And then on line 13, I use the sortable protocol to declare a type var, which will only be bound to types that are either sortable or subtypes of sortable, consistent with sortable, okay? And then on line 16, I use that definition, right? So before we had on line 13, iterable of number returns a number, and now we have iterable of sortable t returns a sortable t, okay? So that's the idea of creating a protocol. You basically are describing a duck typing operation. You're saying, in the context of this function, I don't care what is the type of the elements of the iterable. I only care that they implement the dunder LT method, which is needed to do the sorting, okay? And now we have those things aligned, right? So the tests pass, and also MyPy is satisfied, okay? And we can also show that if I try to pass a list of objects, of instances of objects, the object class does not implement dunder LT. So then I get a runtime error. If I run that says type error, less than not supported. And also I get MyPy reporting that the object in the type of the variable supports less than cannot be object, right? So now this demonstrates that the type checking is working to detect errors, right? And so after we introduce support less than in the type shed, lots of other functions now use it. I contributed the first 6 fixes to list sort, max, min, sorted, median, low, median, high, and then other people implemented using the same protocol in other parts of type shed. Okay, so if you are using if you're using type hints on your code base, please be aware that if you're not using typing protocol, then you're probably then maybe you are using Python in sort of a Java style. Okay, if you want to use Python in a Pythonic way, in a Python style, then probably your code base will need to have some protocol definitions, or you're going to need to use protocols that are defined already in the typing module. There are several, and I think this is going to grow in the standard library. But also, I think that your own code base may find you may find opportunities to create your own protocols, right? So I think it's important that you do have protocols in your typing sometimes, because that means that you're supporting duck typing, which is the essence of Python's data model and the standard library, right? My book is basically about the data model, and Python standard library uses a lot of duck typing as well. The second thing is, one of the solid principles is called the interface segregation principle, which says that client code should not be forced to depend on methods it does not use. And it turns out that this whole idea of static duck typing that protocols support allow you to follow this principle much more closely, because now you can really easily create a protocol near the place where you're going to use it, right? So I have this function that requires, I don't know, a file-like object, but I only care about read. Then I can create a protocol that says I need an object that does read. Okay, in Go they would call this a reader interface. In Python, we would call it a supports read protocol, right? So, and the other thing is you should prefer narrow protocols, right? When you define interfaces with ABCs, which are similar to interfaces in Java, it's common to define interfaces with several methods, although the interface segregation principle recommends using fewer methods. But with protocols, you really need to be minimalistic for them to be useful. And this is the experience of the Go programming language, the Go community, after 10 years of using static duck typing, have learned that the most useful protocols usually have one method or two, but rarely more, okay? All right, so now the last part. So the thing is, I did not like type hints at first, I have to confess. But after the typing protocol came out, then I started liking them. And as I studied them more deeply to do my book, I actually enjoy writing code with type hints more than I did before, and I'm really enjoying using it. But it's also clear that it has limits. And so I'm going to talk about the limits and how to address them. So one example is, for example, the max built-in function I've been using Python for more than 20 years. I never heard of anybody complaining that max is difficult or buggy or introduces problems or makes code unreadable. I've never heard any of those complaints, right? And the documentation is very flexible, but the documentation is not super complicated, what it does, right? Now, the problem is, first, again, as I was studying this, I found this bug. Somebody reported, and it was an example of a false negative. It was an example of the type hint was too open, so it allowed wrong code to pass without warnings. And that was the declaration. So at the time, it was already complicated. You needed 6 lines of type hints. There's this overload decorator that allows you to create different signatures for the same function, just for the sake of type hinting, because in the documentation you see Max has 2 ways of calling it. It requires 3 different overloads to express those variations, but this was too open because the t, you see the t variable that appears a lot is any. So it allowed you to pass any arguments, and many arguments would not work, and iterable of any would not work either, right? So after several hours of study and trying, and also actually asking help, Shelley Gistra from the TypeShed community helped me, because my first solution had 9 overloads, and then he showed me how I could simplify to 6. But the thing is, now on TypeShed, the max function has 6 overloads, right? And to do this, I actually implemented the max is written in C, but I implemented it in Python to be able to test. And this is the code. The bottom half is the implementation that I was showing here, and the top half is definitions. So actually, in this example, there are more lines of code for the type hints than for the implementation of all the functionality documented for the max function, right? So what I'm trying to say is that sometimes you're going to find that type hints complicate your development. Most of the time they are helpful, they catch bugs, but sometimes they may complicate your life, okay? So static typing is no silver bullet. You're going to find false positives and false negatives. You're going to discover, if you're having your first contact with static typing, that you're going maybe to be disappointed that you cannot do very simple data constraints, like the quantity must be an integer greater than 0, or the airport code must be a string of length 3, or the email address must not be an empty string. None of these very simple data constraints can be expressed with type hints, right? So they are not type hints are not going to protect you from those. You're going to have to do unit testing and runtime testing or runtime checking. And type hints are generally unsuitable to check business rules, right? And another thing, as I was researching for this talk yesterday, I found another bug for Max, a new one. I was looking for the old ones, and I found this new one that is, it was closed, but it's not solved because this was filed on the TypeShed, but this Eric Trout, who maybe works for Microsoft, because he's talking about the Pywrite, which is the type checker that Microsoft bundles with VS Code. He's saying this is a limitation of MyPy, right? So MyPy itself has conceptual limitations. It's not, it's still beta software, and it's been quite unstable for this year that I working on my book. When I went back to reviewing the chapters about typing, some things that had some error messages before now had different ones, or no messages, or new messages appear. So it's a bit unstable, okay? Also, static type checkers cannot handle the expressive power of Python. They don't support convenient coding idioms like unpacking. They don't support metaprogramming properties, descriptors, metaclasses, and they lag behind. They issue false reports or even crash when checking new features, sometimes more than a year after a Python release, right? But in contrast, any code that you can write in Python, you can test in Python, right? So the final slides are about good sense that I think everybody should exercise with type hints. First of all, this guy who wrote books about several statically typed languages, he wrote this in one chapter of the best of the software writing anthology by Joe Spolsky. So Bruce wrote that if a Python program has adequate unit tests, it can be as robust as a C++, Java, or C# program with adequate unit tests, although the tests in Python will be faster to write. Now, compared with unit tests, type hints help detect a different and smaller set of bugs. Okay, so they do help when a company has a huge Python code base with already a lot of tests. Then adding type hints will catch some bugs that were not caught before, right? But static type checking complements but cannot replace automated testing. Okay. Also, Python is a dynamic language with powerful abstractions and advanced metaprogramming features, and that's why we like it. And this is something that if you are forced to type hint everything, you're going to have a hard time doing, because some of the powerful features of Python, the type checkers can't handle. Also, teams can only avoid the downsides of type hints if they are not mandatory everywhere. So type hints are not perfect. So if you tell developers that they have to type hint everything, then you're going to force them to have to deal with the problems of type hints, right? My time is over, so I have a few tips here. If you're using MyPy, there are some options that I think are helpful when you're doing gradual typing, and some options of MyPy that are not helpful, that kind of induce typing everything and so on, right? And finally, I want to say that type hints are only helpful if they are used to enhance thoughts, not replace it, okay? And this is a variation of a phrase by Brian Merrick, who wrote How to Misuse Code Coverage. His text is about automated testing, but I also think it applies to type hints. So, domo arigatou gozaimasu. And I would like to be open to your contacts with my email, luciano.ramalho@thoughtworks.com, and also on Twitter, I am Ramalho.org. Thank you very much. I think Hon is muted.
Yeah, sorry for this comment. Always make this error.
Oh, yeah.
Right. Yeah, thank you, Luciano, for this insightful presentation. So for me, I think typing is very useful when it comes to like catching the errors, like what you mentioned in the slide, is those errors that you can't caught in another way. So, and also it helps the developers to document the codes.
Yes.
So,
Totally.
So next we will have Pavia Fore with us. So Pavia Fore is the author of the Robust Python, a book about writing clean and maintainable Python. So he's an organizer of the HSV.py, a local Python meetup focused on growing a Python community. So during the days, he works as a senior software engineer for Canonica, building continuous delivery pipeline for Ubuntu image for public cloud providers. And he also owns Coursera LLC, where he offers the consulting and contracting services. So I will let Patrick to take over the stage.
Thank you, Han. I'm so glad to be here. Thank you so much for having me. So I am going to be talking. Let me share my screen. Let's see here. There we go. I am going to be talking about robust Python. So this is a talk about, this whole entire Forkwell session is about the past, present, and future of Python. We've heard a little bit about some cool features that's upcoming in Python, some features that have existed in Python for some time. I'm not going to talk about specific Python features in that way. I'm going to talk about why we use these features and how they contribute to the robustness of your code base. But first, about me. So, I'm the author of Robust Python. It just went to print about a week ago, so it's brand new. The ebook is available almost everywhere. The print version is available in the US and is slowly making its way to other countries. I started off my career working on lightning detection systems. So when lightning strikes, being able to plot that on a map. I then moved on into telecommunication, and I worked in telecommunication for over 9 years. And now I work for Canonical, and I build Ubuntu images for the cloud, which is pretty cool. As I look back at my career, there's something in common with all of these jobs that I've had. So my lightning detection systems, I wrote some code in 2007. It was operational for at least 10 years. I was a university student at the time. That terrifies me, but it's happened. That code was long-lived. The telecommunication company, a code I wrote in 2009 is still operational. Furthermore, there's code from 2001 from previous engineers that is still operational in their code base. That's 20 years old. And now at Canonical, I'm working on a code base that started in 2007, 14 years ago. I've worked on code that lives a long time. And code will live a long time. Just yesterday, I was fighting a bug that was introduced in 2011, and it didn't manifest until last week. Code will live a long time, and the bugs in your code can live a long time too. Code will outlive your time working on it. People change jobs, they change teams, they go retire to be a woodworker in the forest. anything can happen, your code will probably outlive your time working on it. This means your code becomes legacy. There are many different definitions for legacy code. I'm partial to this one. Legacy code is a code base where you do not have direct communication with the original authors. So why does any of this matter? Why am I talking about this? So, thought exercise. Here's you. You're doing work, it's going great. Here's the amount of tasks you complete in a month. Good job, you. You're doing great. However, let's fast forward a few years. And there's some person, some future maintainer who has to work on your code after you've left. How much do you want them to complete in a month? Do you want them to struggle and only complete a fraction of what you could complete in a month? Or do you want them to be just as productive as you are today? I think we all agree that we want our future maintainers to be just as productive as we are today. You, as you develop software, have a duty to deliver value in a timely manner. But you also have a duty to make it easy for future collaborators to deliver value in a timely manner. You don't want them to go slow. So this whole talk is about making it easy for your future maintainers. Do you want your future maintainers to thank you for your foresight or curse your name? I know which one I'd prefer. So this is where the idea of robustness comes in. And I define robustness as something that is resilient and error-free in spite of constant change. Because let's be clear, your code will change. It's right there in the name, software. The soft part means we're changing code all the time. How do we make it so that we prevent bugs in the future? How do we make it so that it's easier for future developers? Someone's going to be working your code base. You may never talk to them. You may never meet them. How do you communicate to them? So the goal is to speed up those future developers. They will not know your code as well as you do. So it's up to you to give them the best tools for success. You want to detect errors, be able to detect errors through tooling. You want to make your code understandable, and you want to make it hard to introduce faults. This all gets down to communicating intent. How am I communicating my intentions in code to the future? Why do you make the decisions that you do in code? So why do you write a for loop versus a while loop? Why do you use a list versus a set? A data class versus a class, or a dictionary versus a class? We have this innate feeling of why we may do so. I want to talk about why. What is the concrete reasons why we make the decisions we do? So here's some Python code. I have text, I have an index, I iterate while that index is less than the length of the text, I print out that character, and I increment an index. The more savvy Python developers in the crowd might say, well, just write that as a for loop. It's the same thing. And you're right. And if you were to say which one's better, most people will say the for loop. And if you ask them why, they'll say, because it's Pythonic. But that's not really a why answer. Why this is better is it communicates intent. A while loop will always loop until a condition is true or false. And if you're using a for loop, you're enumerating over a collection and doing something to each item of that collection. Here, your for loop is a much more appropriate abstraction. The abstractions you choose communicate to the future. So, robust Python. I ended up writing a book all about this premise. The book is broken up into 4 sections: type checking, user-defined types, extensibility, and building a safety net. Type checking, I think Luciano took a very good presentation about that. I'm not going to talk about type checking. Today, I'm just going to focus about user-defined types. So in my book, I have a few chapters about user-defined types. In the next 20 or so minutes, I'm going to talk about enumerations, data classes, and subtyping. So user-defined types are a way for you to define your own vocabulary. Remember, the abstractions you choose communicate to the future. So if I'm printing a receipt, I take some order, I'm a restaurant, I'm calculating taxes and subtotals, and I'm printing out a receipt. Take a look at this code right here. I have a restaurant which is a tuple of strings, ints, and strings. and I'm then indexing into that restaurant 2, restaurant 0. This isn't very useful if I come across this in code. What is that first argument? What is that second argument? I have to go look through code to figure that out. I don't want to have to do that. If I use a user-defined type, I now have a named type that I can create. A restaurant's a restaurant. That makes sense. There's a city in a restaurant, a name of a restaurant. I've made the code more readable. I've communicated intent to the future by using a user-defined type. Everyone has this mental model of the domain they're working in when they work in your code base. User-defined types can help unify that mental model. User-defined types make it easier to reason about a code base. And user-defined types makes it harder to make errors, which goes back into our robustness definition. So I'm going to be focusing on the why we use user-defined types, not how to create them. I trust you've created classes. I trust that you've dabbled with inheritance. I trust that you've used data classes. Why do we use them the way we do? We often get taught these early on in our career, and I don't think we ever revisit them enough to really examine the inner workings and the why we make choices. So I'm going to start with enumerations. And since this is a global dev study, I am going to start with the country of France. So in France, there's something known as the mother sauces. Heads up, all of my examples are food related. If you're hungry, this will be a terrible presentation for you. It will only make you hungrier. So in France, the mother sauces. These sauces underpin so many dishes in French cooking. They are found in a lot of different dishes. So I've listed them here as a couple of strings. And I have a function to create a daughter sauce. So what happens here is you take a mother sauce and you add some ingredients and you're creating a derivative sauce from it. Sounds good. Except, I have mother sauce 0 here. Anyone who was paying attention 2 slides ago, what was mother sauce 0 again? Well, you got to go all the way back through code to figure that out. It's easy to make mistakes. Instead, well, I should say, the reason it's easy to make mistakes is because mother sauce is a string. It can be anything. So I can say, this was bechamel. That makes sense. I'm creating bechamel with onions. Not bad. But I could also say barbecue sauce. And if I do this, I make the entire country of France mad at me, I am pretty sure. So we don't want to do that. That's just flat out wrong. This is an error that can creep into your system. Speaking of errors, I mentioned bechamel. Who noticed that I left off an accent mark in my string? Have fun debugging that in production. Errors can be egregious or they could be subtle, and you want to make it so that people who don't know the code base as well as you do not make them. So because strings can be anything, I want to use enumerations to restrict choices. So here I have an enumeration for my mother sauces, and I can just access it with mothersauce.bechamel. And now, when I take a look at my code, instead of using a string, what I can do is I can use an enumeration. And I've now made it so that it is easily detectable if I do something wrong. I can't pass barbecue sauce into here. The type checker will complain and catch errors. I'm letting the future know more about the code because of the tooling I put into place today. You catch mistakes with static analysis, linters, type checkers, and the like. So you use your enumerations to prevent collaborators from using incorrect values. So use enumerations to simplify your choices. Preventing bugs is the name of the game. So enumerations are good. They represent a single value, a choice of multiple values, but ultimately it's one single value. What about composite data? And for that, I'm going to talk about data classes. You saw them in Lukasz's presentation. Data classes represent a relationship between data. Let's imagine I have some data in my system, an ingredient list, author's name, author's life story, because every recipe needs to have an author's life story, I feel like. Pages long. I'm kidding. I can't stand them, but they're always there. All this data is tied together, and I want to group it into some online recipe. Okay, this is a relationship between data. With a data class, I compose all these individual pieces into one logical abstraction. No one has to manage all these things individually. They get it as a package. So I can create an online recipe, I'm making pasta with sausage, one of my family's favorite dishes, author, a life story, a number of servings, ingredients, recipe, you get the gist. And I can access these fields, recipe.name, recipe.number of servings. Great, I'm communicating intent. Data classes represent heterogeneous data. Heterogeneous data is data that may be multiple different types. You can have strings, ints, list of ingredients, whatever you think of. It's typically not iterated over. You access a single field at a time. Do not do this with heterogeneous data. Do not use dictionaries, because dictionaries do not communicate intent to the future. I see this a lot in code bases, and if anything you take away, do not use dictionaries for heterogeneous data if you can get away with it. The reason why is, say I have some function that takes a string, maybe it's doing something with my life story. Has life story the right key name in that dictionary? You have to go back and look at the code, and with dictionaries, you'd have to look at every single place that someone has instantiated that dictionary and or modified it to make sure you've caught all places where keys can change. Furthermore, if you try to type check this, well, what type is recipe? Like, it's a dictionary. Should it be if I'm type annotating it, should it be a dictionary of a string mapped to a union of strings, ints, and lists of ingredients? It's ugly. I don't want to do that. Anytime a developer has to trawl through your code base to answer a question about data, it wastes time and increases frustration. If you're working in a code base that has thousands, tens of thousands of lines of code, this wastes a lot of time. This will create mistakes and incorrect assumptions, and this will lead to bugs, which we want to avoid. So, furthermore, the data class, your type checker can catch problems. So if I do recipe.lifestory, my type checker will say, hey, life story is not a valid field of that data class, which is great. And I can annotate, which just solves that communication of intent. So you use data classes to group data together and reduce errors when accessing that data. You communicate intent, and you're preventing future developers from making errors. So data classes aren't appropriate for all heterogeneous data, though. And to explain why, I'm going to talk about invariants. So an invariant is a fundamental truth throughout your code base. Developers will depend on these truths, and they'll build assumptions on them. They're not universal truths in every possible system, just your system, because that's the system that matters. So for here, I'm going to jump to Italy and talk about pizzas, because we all love a good pizza. So here's some invariants I want to define about a pizza. Sauce will never be put on top of other toppings. In this case, cheese is a topping in this scenario. There are pizzas in the world that put sauce on top of cheese, but for my system, I'm disallowing it. Toppings may go above or below the cheese. Pizza will have at most only one sauce. The dough radius can only be whole numbers, and the radius of the dough may only be between 15 and 30 centimeters. So with a data class, I could represent the pizza with a radius and a list of toppings. But the problem is I can create that data class just fine, but I am free to mutate those fields however I see fit. And that's bad. You're relying on developers to go look through documentation to find those invariants. It's probably not going to happen. That documentation might be out of date or non-existent. So this is where classes come in. I use classes to represent an invariant. So instead of this data class, I'm going to create a class. Apologies for the length of code on this slide. It's a constructor. It's taking in radius and toppings. But the important part is I'm doing invariant checking inside my class. If I cannot construct a pizza that meets all of my invariants, I will not construct it. So I am preventing users from creating invalid data. Developers, I should say. Now, when I try to say, give me a pizza that's a meter radius, while I would love that as someone eating the pizza, as a business case, I might not want to produce that. It now throws an exception. It's not hidden in a runtime problem that doesn't throw any exceptions that you only find out when a customer screens. Furthermore, what helps out here is you might notice that I have these double underscores for my members. These are private members, and I put private in quotes. They're not truly private, but through convention, they should be. Linters can catch when you try to modify or mutate private members. So you can protect your invariants so that nobody can invalidate them. Classes can create those invariants. Developers can't modify them. The important thing is, for people to reason upon them, classes must always preserve those invariants. Here's an add topping function inside my pizza, and it is doing all of the same invariant checking to make sure that I don't break any reasoning someone has on top of me. If your class doesn't have invariants, it's probably better as a data class or as free functions outside of a class completely. Classes are heavyweight, but they can help just a whole lot with creating invariants and maintaining them through your system. Give your future collaborators solid classes to reason upon. So again, they allow you to group interrelated data and preserve invariants across their lifetime. I have a little flow chart here. If you have homogeneous data and it's scalar, use an enumeration. If you're mapping keys to values, use a dictionary. If you have heterogeneous data, ask yourself if you use invariants. If you don't, look at a data class. If you do, look at a class. This is what I use to decide what type of user-defined type I'm creating. Now, I want to talk about subtyping before I leave today, end of this presentation, because it's something that people get wrong quite often. So subtyping is a relationship between types. A subtype has all the same behaviors as a supertype, and it may customize some of those behaviors. Most people are familiar with inheritance as a form of subtyping. I have a rectangle. It has a height, a width. I have setters. I've elided over the getters. But I also have a square. A square is the subtype of the rectangle. The rectangle is a supertype. I'm inheriting from a rectangle. I can override how I set the height and set the width so that a square has a consistent side length all the way across. Makes sense. But what I've just shown you has a very, very subtle error that bites a lot of developers. So to show you, I'm going to talk about some mapping software. This is a map of where I live, at least nearby. And I'm going to say I have some food trucks roaming around, and these are their zones of influence. These are where they can drive around. And let's say we're writing this mapping software, and we want to be able to manipulate these squares and rectangles. I have a list of rectangles just to show these are associated with my food trucks. And I'm going to ask you a question. Is a square a rectangle? Now, this shouldn't be like calculus level math. This is things we learn as young children. Yes, a square is a rectangle, geometrically speaking. Tougher question. Is a square substitutable for a rectangle in all cases? And now you have to think, because that's a little bit harder of a question. If I take my food trucks and I take that middle rectangle and I change it to a square, is that fine? A lot of developers think that's a perfectly okay thing to do. And the answer is it depends. Here's a case where it's not. So let's see what can go wrong. I have a function that doubles the food truck area widths, and it assumes that I have a list of rectangles, say. I get it for every food truck shape in that list of rectangles. I get the width, and I set the width to double what it was. Quite simple. What happens when that shape is a square? Well, when I set the width, I will set the height as well. So let's go back to that original code, and let's say someone assumes I have these rectangles, and they say, you know what? I found a bug. I want to write an assert that the height does not change when I double the width, because it's a rectangle. The height should not change when I double the width. Now when someone substitutes a square, maybe years later, it breaks. It will break this assert. And if this assert doesn't run all that often, maybe it's hidden behind another bug or whatever, you might not catch it in your unit tests. You might not catch it in your integration tests. It might make it to production and spend years until it surfaces. Again, I just fought something like this yesterday from 2011. Developers will write code based on the constraints of the superclass. After all, that's what they see. A subclass is meant to be substitutable for. Do not let your subclasses violate those constraints. Someone changing a superclass should not need to know about all possible subclass variations. For all you know, those subclasses might not even be in your code base. They are provided through plugins, or it's a library that someone else is including. You might not even have access to the source code the subclasses are defined in. And at heart, this is one of the solid principles. This is the list-called substitution principle. It's all about substitutability. There's a much more formal definition that I am eliding, but it comes down to do not strengthen your preconditions. Do not restrict whatever the superclass allows. Do not weaken your postconditions. Don't, if the superclass gives a consumer something, your subclass needs to as well. Do not raise new types of exceptions. I'm looking at named not implemented errors specifically. There's nothing worse than relying on a base class or a superclass, seeing that it throws no exceptions. Someone puts in a subclass that now throws an exception, like not implemented, and I have no try excepts, because why would I if the superclass had no concept of exceptions? Further, overridden functions almost always should call super, because if the base class changes, the superclass changes, you want your subclass to change as well. So I was talking about inheritance. People call inheritance as is a relationship. A square is a rectangle, and I want to get away from that. A square can substitute for a rectangle. So when you think about inheritance or subtyping, stop saying is a relationship and start saying can substitute for a relationship. Inheritance is not the only subtyping. Luciano talked about duck typing and protocols. Those are subtyping as well. There may not be a named type as your supertype, but a type is just a set of behaviors that's still subtyping, and all of these rules apply. Same goes for plugins. Even at a system level, if you're replacing a microservice, there's a contract you have to uphold. The same sort of thing applies. How you subtype will influence how easy it is or how hard it is to make errors as code changes. The choices you make in code may reduce future errors. The choices you make in code communicate to the future. And remember, the abstractions you make in code also will communicate to the future. Software development is both archaeology and time travel. You're looking to the past, trying to figure out why something is the way it was. At the same time, you're communicating to people 10 years in the future that you will never meet. So some tips for writing robust Python is don't rely on the developer's memory or their ability to find all usage in a code base. It's a flawed endeavor, and even if they're successful, there's a lot of time wasted. Communicate your intent through deliberate decisions in your code base. Type annotations are a great way for doing this as well. Make it hard for developers to do the wrong thing. Make them succeed by default. If a developer does the right thing by accident because it was the easiest thing to do, you've won. You've eliminated future bugs. And when those bugs inevitably will happen, use tooling to catch them. Linters, type checkers, etc. You have a duty to deliver value in a timely manner. You have a duty to make it easy for future collaborators to deliver value in a timely manner. After all, you're going to step into a project one day that's legacy. How do you want that code base to look? So that is my talk on robust Python, specifically user-defined types. If you're interested, like I said, I have a whole book about it. There's a link to the bottom for a free 1-month trial for O'Reilly, where you can view the entire book in its entirety, as well as Luciano's as well, completely free of charge for 1 month. So please take a look, check that out. If you need to contact me, please give me a shout out on Twitter. I have a blog. I also do contract and consulting. You can reach me through there as well. That's all I have. Thank you so much, Forkwell, and thank you, Global Dev Study, for giving me the honor of speaking here.
Right. Thank you, Patrick, for this awesome presentation. How many slides that you have? I think your slides so many.
Oh, I have 158 slides, I think, but most of them are like a sentence long.
Wow, that's a lot.
I'm terrible. I create too many slides.
No worry. It's cool. Yeah, actually, I totally agree with you. Like, as a developer, it's always a nightmare to manage the legacy code base. Yeah, I always do not know how to start to read them. Yeah, when I get a new legacy code base. Yeah,
legacy code doesn't have to be a nightmare. Make your changes today to make sure that you're communicating in the future.
Yes,
it's only a nightmare if that foresight is not put in.
Yes, yeah, that's why it's very important to write a clean and maintainable code at the first. Yeah. Right. So let's begin the Q&A session. So with Lucas, with Luciano, and Patrick. So if anyone want to ask questions, Yeah, please scan the QR code for the Slido and ask questions from the platform. Right. So, okay, the first question here. Right. I would say that the first question is like, what is the difference between the regex and the pattern matching? Like, could I mix them together? Yep. I think this question is for Lucas.
Well, regular expressions are a form of matching. However, they encode sometimes very, very well, big arrays of possibilities into a very tight space of a single regular expression. Even if you're using the verbose ones where like white space doesn't matter and you comment them and whatnot, like it's still a rather cryptic, well, you could say non-Pythonic way to express what you need. And pattern matching is more about kind of more large scale patterns that you're seeing. So while you might kind of still match a certain things that you see in strings and whatnot, it is more concerned about like overall structure. Like, so I think it's very well suited towards, the example I gave, like about like, hey, you got a dictionary, say from JSON and whatnot, because you can do different things depending on the number of elements in a list, or depending on the type of an argument and whatnot. So things that you cannot really do inside a single regular expression, because here, like, you're gonna have a limit of like, this is for sure a string, only it can have different content. Like with pattern matching, we're like, there's data there, like might be of different types, might be of different kind of, well, alignments, might have different shapes in terms of like whether something is a scalar or a collection and whatnot.
Right. So I think there's another question here. Is like, how about implementing the data class with an initiate and adding the topping private for the invariance? Yeah. So right. I think this question is.
So you can absolutely implement a data class with an init method, add toppings, and private invariants. If you're going to do that, just write the class instead. So if you think about this end of Python, there's should be one way of doing things. There's multiple ways of doing something, but there's one intended way to do something. So I say class should be used for invariant handling. Data class should be used for pure public access. That aligns with what a developer's expectations are. And you're not going against the grain, trying to make a user-defined type behave it like a different one. I also equate it to like, you can do any loop with a for loop, a while loop, or recursion, but you would use those, you wouldn't just interchange those freely. They mean certain things. Treat your user-defined types the same way. Use data classes for specific cases and classes for specific cases, and don't cross the streams with that.
Right. Okay, cool. So there's another question here for Luciano. Like, when should I use the optional type hint?
So thanks for the question. Well, the optional type hint is actually a shortcut for a union of one type, of some type, and none, right? So you use it. It's a pretty common case. That's the case where an argument, for instance, may be none or maybe an integer, something like that. There's an important thing that Pat's talk. He talked about that you have to be more strict about the types that you return than the types that you accept. That has to do with the Liskov substitution principle and also the so-called robustness principle. So although optional is fine as a type for an argument, it's not so great as a type for a return type. Because if you're returning something that's optional, then the user who is calling your function has to worry about the fact that this thing may be a none or maybe something else. Right, so ideally, you should avoid optional and unions in return types and use them mostly for accepting arguments.
Right. Right. Understand that. So yeah, I think these two questions are for Lucas. Like first question is, are there any plan about the Python certification? And yeah, second question is, I love pattern matching. Like I want to have a mechanism to prevent unreachable branch. Like MyPy will become to do, like would MyPy able to do such a job in future?
Cool. So first, certification. So the Python Software Foundation has looked into this in the past. Like I don't think there is anything that is in motion for this at the moment. There are, kind of upsides and downsides to certifying certain kind of knowledge. So the worries there were that, like the certification scheme always works around testing some particular knowledge and just grades you on it. So in certain ways, it might kind of reward mediocrity because, kind of you're kind of rewarding a particular skill set that might not really represent, actually being good at Python or not being good at Python and actually being a good developer in the end. So, kind of also, like, should it be free or paid? Like usually those things are paid because just conducting the certification and issuing the certificates is not a free endeavor. But that way you're actually excluding some people who might not be able to pay what you want. You need to remember that the Python Software Foundation is an American entity, so pricing that makes sense in the US might actually not make any sense in different parts of the world. So in the end, I do think that whether we're going to have or not certain certification schemes for Python that are in any sense official, so conducted by the PSF, is still an open question, but I wouldn't hold my breath personally. And just not speak too long. Like the second question, pattern matching. I personally hope that we will actually have type checkers able to ensure that all the matches that we are looking into are exhaustive. So that would allow us to do wonderful things like Rust, which kind of works around not having exceptions because their optionality has to be it has to be exhausted, right? So you need to follow all paths that are possible for a given type. I'm not sure this is being tackled at the moment. MyPy's development slowed down a little when Dropbox stopped actually actively being involved in this project. But this sounds like one of the reasons why we went into pattern matching right now or not. Definitely something to look into the future. It's not a possibility at the moment yet. No.
Right. Yeah, I understand that. Yeah, it's not for now. Maybe we will have that in future. Right. Okay, cool. I have a few questions for Patrick. How would you know if you have written a readable and easily maintainable code?
Yeah. My advice here is to look around you. Look at your junior developers in your organization, if you have any. How are they handling code with fresh eyes? They're struggling, that might tell you something. Do data analysis on your bug reports. If you find bugs in a lot of the same file over and over again, if you have bugs now, you're going to have bugs later, is what I've found. And take a look through your source control. Which files change the most? Which do you have certain commits that have to touch 20 files at once? Anything that you do now with full knowledge of the code base that is difficult, it's going to be exponentially difficult later on for people who do not have the full knowledge that you do.
Right. Understand that. Yeah. And then I have another question for Luciano. How to specify the multiple return type using a type hint?
Oh, that's a very good question, because I just talked about trying to, as much as possible to avoid returning union types or optional types. And that also has to do with that. So usually, and I did other presentations, I think at PyCon and also at PyLadies Munich, that are recorded in English, where I go deeper into protocols, and in the process of solving a problem, I use some of these solutions. So usually what you want to do is to use a type variable, because usually if you're talking about multiple return types, it's probably because they depend on the inputs. right? And so the way to connect the inputs, the arguments with the outputs of a function is via type variables. So you need to learn to use type variables in order to solve well the problem of returning different types instead of abusing. Sometimes it's impossible, and then you use a union. But you should try as much as possible to be more informative and be more precise in the return. And the way to do it is with type variables.
Right. Okay, cool. So another question for Lucas is like how to use the value stored in the variable as a case pattern.
So when you are matching a particular expression, whenever you're using a name that wasn't bound before, those names are going to be available for you inside the case scope, so you can use them as variables. However, for example, if what you're matching is an entire object, like in the example I gave in the talk, there was like a movie that had some title and there was like some other things. So like you cannot get that entire movie back, like unless you just take the variable from outside of the entire match statement, right? Which is what we did. But other than that, like what there's no way to get to that anymore. Like I haven't actually tried, but now I'm thinking, hey, we have assignment expressions as well. So like maybe there's a way to just bind a name to some larger structure. Like I would have to try that out. But pattern matching itself matches names that have not been bound yet. So like those are going to be used for like new variables for you that you can use inside the case block.
Right, understand. Okay. All right, cool. So yeah, we have a few questions more. Right. Okay. So this is a question for Patrick. Like, what are things to aware when you are refactoring a legacy code base?
Yeah. Keep backwards compatibility in mind. Lots of people depend on lots of parts of your code. You don't want to break them. Don't try to refactor everything at once. Be strategic. The things that have lots of errors are difficult to understand. And you always want to think about the value of that refactor. Like, I don't refactor just for the sake of refactoring. If that code isn't changed and isn't looked at for years, you might be wasting your time. It might be good for a personal gratification, but for helping the future out, your time is better spent refactoring places that is more frequently traveled or has more bugs.
Can I add something?
Of course.
Yes, of course.
Yeah. So you can consider adding type hints. This has been shown to be very effective in companies that have large code bases of Python 2.7 code to migrate to Python 3. There is there's a comment syntax that you can use to put type hints in Python 2.7 code, and that has been proven to be very effective to help migrate code bases to, if that's the kind of refactoring.
Yeah, and I'm going to broaden that further. Build an entire safety net. Type hints, linters, testing. Don't try refactoring without those, because you want tooling to catch those errors, not production.
Yes.
Totally agree with this. Yes. All right. Yeah, we have three more questions here. Like, so I just open to any speakers to answer it. First one is it possible that half of my variables use the type hints and the other half doesn't use the type hint? Anyone? Or maybe Luciano? Yeah, I think this is the part.
Okay. Yeah, it's possible. In my experience, you rarely need to type hint variables, because usually variables are holding the result of expressions, and the type checkers are smart enough to infer the type. Sometimes you do need to type hint variables, but it's most of the time you don't need. And in general, it's like one of the points that I made in my talk. I think it's not productive to be very obsessive about type hinting everything, because that's going to, in the end, cause some costs. There's a diminishing return, you know. Up to a certain point, you're gaining by adding type hints, and beyond a certain point, you start complicating your life without getting a lot of benefits. But yeah.
Yeah, like let me just add one thing. So, whenever you have a code base, say you want to include typing in it, like there's kind of an order in doing so that will be less painful, and an order that's going to be more painful. So imagine that your system has a library that a lot of code later uses, right? So it's like a central piece of code that you have. So I would argue that you would need to type that first, and only later move to the kind of leaf code that uses your library. Like, why? If you type leaf code first, that is going to be like a very good experience. Like you type your inputs, you type your outputs, and there's barely any error here, you know, like all seems to be good. But only after you start typing more code, so the type checker actually reaches deeper and is able to analyze more about what is happening, it will now start identifying errors that you have in code that you already typed. Because before, when you call code, which is itself not typed and it's not standard library, the type checker will assume that, well, the type of this is any. It can be literally anything. I don't know anything about it. So the type checker will not reach into bodies of functions which are not annotated. It will just assume this is not typed, so this is anything. So once you start annotating those functions that you're calling, it might actually start identifying issues in code that you thought you already had covered and it was fine. So it's true that it's, you know, kind of hard to annotate an entire complex system, because some of your parts are going to be very dynamic, and the result of that is kind of, you know, yeah, okay, you identified maybe an error or maybe not even, but spent a lot of time on it. But if you're introducing type checking to your existing software, you should start looking at the pieces that are used, you know, very much somewhere else. So essentially, just drawing the graph of usage, right, like a dependency graph, and seeing, oh, what thing is the central piece of code that I need to start with first, and only then go to the leaves.
Right, understand that. Well, yeah. Patrick, do you have anything to add on? No. Okay, so here's a question. Another question. What is the biggest challenge that hurts the maintainability?
For me, it's when a developer writes code, gets it to work, and thinks that's good enough, and not considers, is this communicating the right thing to someone who reads this code later on? Code is read far more often than it's written. So I prefer to optimize for the reader. Secondly, when assumptions change, and they will change in your code base, making sure that you're reflecting that in older parts of the code, so that when someone does that archaeology 5 years later, they have a clear trail of, oh, this is a better reflection of what the code is supposed to do.
Right. Would Luciano and Lucas have anything to add on? I think these are all, everyone can answer this question.
Well, I find that, you know, kind of when you're thinking about your code in terms of how I'm going to be testing this, like that usually ends up with APIs that are kind of more maintainable later and lend itself better for refactoring and whatnot. The reason for it is, for example, that if you're not thinking about testing first, at least, you know, you're not thinking about the coverage of your testing, it's very easy to create situations that are very hard to reproduce in kind of clean room environment, right? So tests are usually clean room environments. You're creating a bunch of objects, and then you just try to invoke a function and see if it does what you wanted. There's no entire kind of environment of production. So maybe there is some configuration you need to fetch from somewhere. Maybe there's some data source that you need access to, and whatnot and whatnot. But even if this is not so complex, when I first started contributing to config parser in CPython, we had like 99% of coverage for config parser. And I was like, no, I'll get it to 100%. And it turned out that the places where we didn't have coverage were kind of very, very obscure exceptions that didn't happen often. Because, for example, somebody defined the same section and configuration twice, and we didn't have a test for that. Or somebody used some weird character while, trying to create a new value, and that didn't work. So essentially, the blocks that are in except statements, right? Like the except something and something weird happened. So when I started actually constructing cases for those, which sometimes wasn't actually that easy, I found 4 bugs actually, like that were like in Python for like all that time. Config parser is one of the oldest libraries that we have in the Sun library. And so it just goes to show that, if you think about testing stuff first, it would probably not end up in this situation, right? Because it would not be so hard to even start with this testing, which is why our developers kind of, they didn't want to or were unable to put tests for that particular piece of the Stan library for so long. And I'm pretty sure there's more stuff like that, like in both in CPython and in other code in the wild. So yeah, one advice I would have is just think about how would you test this.
Yeah, I agree, and I would say that one of the best ways of thinking about testing is to do it first. At ThoughtWorks, we are very big fans of TDD, and we find that naturally a code base that is developed with TDD ends up with about 95% of coverage, and that's good enough for most cases. There's another thing that I would like to say is they say that naming things is one of the hardest problems in computer science. I agree, but it's also super important to communicate with the future, like Pat said. And my suggestion is use a thesaurus. I use one that's called the Princeton WordNet. Google for Princeton WordNet. I use it all the time, every day. Actually, I have a fixed tab on my browser because it allows you to search for words that are more precise to describe what you want to describe. Sometimes you have words that are vague, like activity. So what's an activity? And then you go to the Princeton WordNet, and they have many synonyms or related words to activity that may be more precise. So that's my suggestion. Be careful, be mindful of the names that you choose, and use a thesaurus to find precise names.
Yeah, understand that. Cool. All right. So we'll proceed to the last question here. I tried to use protocol before, but my experience was that the error message was very cryptic. I'm not really sure what he mean by cryptic here. Do you have a similar experience, or do you have any tips?
I would like to say something very quickly, but I also would like to hear Lucas' answer because he is one of the authors of the PEP that created protocol. And of course, Pat can chime in as well. But what I want to say is, although I think protocols are very important, what I learned trying to teach it in presentations that are sometimes very time constrained is that there's a lot of moving parts, right? You can't really use a protocol without a type variable, and then you need to understand what the bound keyword is in the type variable, and that's kind of subtle. So maybe that's the reason why protocol error messages are difficult to understand for somebody that's using a protocol, because you need to understand all those moving parts that are part of it.
Yeah, so what I would say is that, again, the PEP doesn't really describe how error messaging should work and when there's something wrong with either defining a protocol or when matching a protocol. It's more of a responsibility of the type checker to kind of provide sensible messages here. And my experience here, working with 1.5 type checkers, so I've had my stint with MyPy, but also at Facebook there's a type checker called Pyre that is used extensively there. is that, it's very easy to produce error messages that map very well to the data structures you're using internally in the type checker, but those are not necessarily very clear to the end user, right? So when time comes and you have kind of the energy to spare, you can improve that experience a lot by actually making more high-level error messages. And this is what we did with Python in Python 3.10, right, and continue doing for 3.11. And I notice how late that came, right? Kind of Python has been along for like 30 years, and only now we're just telling you where the syntax error is. So obviously I do agree that the more complex the types are, like the error messages can be very verbose. So that is what the user meant by cryptic, but also kind of the fact that when you're matching a particular place where types disagree in a type error, sometimes it's kind of, you need to use some implicit variables or names like in that error message yourself. And that kind of takes quite a while to decipher which is this part that disagrees. I don't find this a problem that happens in most people's code, because in most people's code is essentially kind of embarrassingly easy in terms of types. The more dynamic it is, that changes the complexity. So protocols, I think, are going to be mostly useful in terms of, you're defining what you want that is typical. Because if it's typical, maybe your code would work with some arbitrary sequence of strings, but you still want to just say list of strings. It's just easier to understand for humans. It's easier to check and whatnot. So I think, so in this sense, typing is going to influence how people write their code, because they won't be relying on such dynamism as we had before. For example, instead of just writing a custom protocol to just support read lines or whatnot, they'll just say IO of text or IO of bytes and be done with it. Now you're supporting everything. Is that hurting much? In all honesty, not really, because you're using files in any case in production, and if you need tests, you can use string IO or bytes IO that do the same thing. They actually have very good mimicking of other IO types. So to just draw this home, of course, the error messages can be improved and should. This will mostly happen where they happen, which is in type checkers. For Python itself, we don't really produce many errors for the typing module. So whenever you're seeing an error that is probably something kind of basic, I don't know, really putting a non-type where a type should go, or just any other low-level Python error, like a name error or syntax error. Yes, but I would just advise you to try it out, and if there are any repeatable problems with it, we will always be improving it. So we still are kind of early in its adoption. So whenever we get real world experience with that people, users, you provide us, we will be able to do better next time, right? In the next iteration of whether it's CPython or a type checker.
Okay, cool. Right. All right, cool. So, Patrick, do you have anything to add on before we end the session? Okay, cool. So, right. Before we end the session, I would like to ask all our speakers here, what is a last message, one sentence message that you want to share with our attendees here? Maybe you can start with Lucas.
Yeah, so my message would be Python is very special. It's probably the most special language that we have, because it's so big in teaching, in data science, in web development and whatnot, but it's not controlled by any single corporation, right? It's not a darling of some multi-billion company. It is in fact kind of a work of volunteers. You can be one too. So you might look into actually contributing to CPython. Now we have a full-time core developer whose job is literally to go through pull requests and issues filed by users. So your experience might be better than it was until now, when some issues weren't really looked at very timely. but also you might just kind of start doing this work yourself. And if you find that this kind of work is valuable, please sponsor the PSF. The PSF makes it all possible.
Cool. Right. How about you, Luciano?
Well, thank you very much for having me. I'm honored to be with those guests, also Lucas and Pat. I want to say that Python is a fun language. It's one of the things that attracted me to it, that it's fun, it's powerful, and it's like Lucas said very well, it serves a very big and very diverse community, right? So we need to respect that and understand that things that may be a super important feature for you maybe are not important or are even undesirable for other parts of the communities. And that's okay. You know, that's how Python grew, by catering to different kinds of people, and hopefully it will continue to be like that. And a great indication of that is the conferences. Just if you go to a Python conference, you're always going to see a huge diversity, not only of the people speaking, but the subjects that they talk about. People talk about physics, about social sciences, about finance, about lots of different things, not only related to the domain of IT. So, thank you.
Right. So, how about you, Patrick?
Yeah, I'd say the people you've worked with, the people you work with now, and the people you will work with are all awesome human beings who have their own hopes, goals, dreams, and challenges. Remember to think that they're not just a name on a pull request or a screen name in your organization. Practice empathy. Writing code is an exercise in empathy for the future and those around you. Go build awesome things.
Okay, cool. Thank you. Yes, I just want to say a big thank you to all the guest speakers here, like for taking the time to share the knowledge and also the very interesting, insightful presentation to our attendees here. And also thank you to all the other audience for your active participation. So I have seen a lot of good quality questions here. So thank you everyone, and we hope to see you again in the future Fogwells events.